you're going to go mental? Which one is it? Both. Okay. Yeah, it's on. It's definitely on. Why do I not have very many subscribers? I don't know. Okay. So we're going to start with what you already know. Okay. We've been calculating integrals quite regularly lately, right? So let's start with this. Now, again, be aware of the number of ways you can be asked this question. Okay. How can I be asked this question? I could say calculate. That's the easy version, right? What else could I say? Well, we could say, what is the area under the curve, under the graph, I should say, if I'm being proper. F of x equals x cubed on okay, there's one way. You could also say between the x-axis and the graph of the function. Okay. So again, keep those in mind. There are many ways you can be asked that question. So, okay, somebody tell me what to do.
First start with the
okay, so we have the antiderivative, x to the fourth over 4, evaluated from 2 to 4. Right?
yeah.
I don't know what you're talking about.
It's 56.
Now, you normally have to keep track of me, but today it's probably going to be worse. So, it was okay. We did trig identities and pre-calc, and I did okay, so I think we're going to be okay. So, are you sure?
No. I'm pretty sure it's 56. No.
No calculator.
Number. What's 4 times 4?
4 times 4 is 16.
16. 16.
64 minus something.
256. Minus, what's 2 to the 4? 2, 4, 8, 16. So this is, okay, good. So you can do those problems, right? You're better than math teacher problems. Which I don't know if that's a shame or if that's a good thing. You certainly get a lot more practice out of it. That's, yeah, very much so. Okay, let's try another one. Math trig. So we have integral from negative power 4 to power 4 of secant squared x. Okay, go. Sure. You're already on it. I don't know why.
I'm just guessing.
Yeah, you're all saying it right. It's correct.
So, what's different about this than the last one?
We're getting there.
Trust me, it always gets worse.
We're getting to the catch.
We're getting to the theorem. All the theorem does is tell you how to do this in general. So I'm just kind of cycling the knowledge that you have, right? Tangent of power 4 is 1. And negative power 4 is 1. Isn't it? No. Yeah. Okay, now let's talk theorem here. You all went, many of you were at the session, you went through the theorem section with me. We talked about conditions, correct? Okay, what conditions are necessary for me to be able to calculate the area under a curve? Does it have to be differentiable? No, it doesn't. It has to be continuous. Okay, so for this to work, we have to have continuity, right? What else do we have to have? Now we're looking at a closed interval now, right? Okay, we have to have an antiderivative. So the fundamental theorem of calculus. If we're going to generalize this, okay, we have some numbers. It's called a derivative. I'm going to add something your book doesn't have in it. There is something missing here, right? Okay, so we have to assume, so this is the fundamental. Oh, I should write that better. Cursive just does not work on these words. Fundamental theorem of calculus. So we have to have that f of x is continuous on AB, right? We can say the next thing two ways. F of x, big F, is an antiderivative okay, do you agree with that statement? If I write it like this, f of x is an antiderivative, big F, right? How could I rewrite that using a derivative? I could also write it this way. And actually, that's how you will most often see it. This whole statement can be summarized with that notation. Now, it's kind of counterintuitive. It's basically you're saying the derivative of f is little f. It's true, it's just backwards to what you would normally think it. Okay. So be very careful with that statement. It is true. It's just backwards the way you usually think it. So the fundamental theorem of calculus just generalizes what you already know. You have the antiderivative, correct? That's what we did here. Secant is squared, the antiderivative is tangent, so we have little f, the antiderivative is big F, evaluated from A to B, is f at B minus f at A. This is f at B minus f at A. Okay, just, we got you calculating all these answers, now we're just generalizing them. Okay. So basically this tells us that what we're allowed to do. We're allowed to calculate it. We will get into some theory-based questions tomorrow. It's not a notes day, it's more of like look at AP-style questions, decipher them, solve them. Okay, so there's the theorem. Continuity on a closed interval. That's all you need. All right, let's, do you want to evaluate another? All right, we'll come. Don't worry. It's a big game.
Is that it for homework? So, wait, what was it?
I want to just make sure we're good with two more integrals, and then we'll be done, okay? The other one. Okay, these two and we'll be done. Okay, antiderivative K, go, since you're focused. I agree with part of that statement. Because you calculated the derivative, not the antiderivative. Okay. What?
Wait, so all that's different when you calculate the antiderivative is you literally divide instead of multiply? And then you add
Right? This will probably be one of those calculator-friendly problems if you're asked for a decimal answer. Right?
Yeah.
So, if you do put it in the calculator, I believe the answer comes out 0.692. Okay. What? Oh, here? Wait a minute. Yes. Are we good there? With the E? We're done. What do I think it is? What do I know it is? Take your pick. Okay. Cannot exactly. That's a good question. You can rewrite these if you need to. Is that a little more clear? Yeah, a little feedback would be helpful here. Yeah, you can rewrite these if you need to. What is the antiderivative of 1 over x? ln what?
ln, yeah.
Don't forget that. Because if you didn't put absolute value here, this would be, you couldn't evaluate it. Okay, so this is probably going to be a no calculator problem, and you're probably going to end up with this answer as a multiple choice answer. Or even this answer. Do you remember how to get to that point?
No.
This is not change of base, it's still natural log. Okay. Properties of logs. Remember, if you have two logarithms with the same base, subtracted, you can combine and divide. Okay. What if it was addition? Combine and multiply. Okay. So if it's subtraction, you can combine and divide. Right? Any questions? Sarah? Okay, fine. Can I move on? Okay.
Is this due on Thursday?
Yeah. Okay. And start.
I was confused.
Okay. Do. Thursday. Okay, you're probably going to see some more difficult antiderivatives. So if you get stuck on them, just shout. We'll have, you have 15 minutes today and probably another 20 or 30 tomorrow to work on this. So take your time. If you can do it by hand, don't use a calculator.